Hello, welcome back. In this tutorial, we'll try to understand the next part of Numpy, and this is basically all the mathematical advanced and basic mathematical operation which are possible with Numpy that I'm going to cover in this tutorial. So let's try to understand, figure out how the Numpy works for mathematical operation. So it's a numerical library. So it is going to do a lot of numerical operation possible with NumPy. So let's try to understand how it actually works. First, I'm importing NumPy as NP because I'm going to use NumPy again and again. So instead of writing NumPy, I'm going to write NP inside that. Okay. So the first operation which I'm starting is very simple, the addition of two number, and then the subtraction of two number, the multiplication of two number. Okay, you can just write down multiply, np dot multiply, np dot divide. Very simple operations. Okay, these are the simple four operation, arithmetic operation are possible. So now let's go to the next one. Suppose you have the a range operation 0 to 9. You can just check out the true division of that. True division means each value will be divided by 2 and the value will be presented over here. 1 divided by 2 is 1 0.5, 2 divided by 2 is 1, 3 divided by 2 is 1.5. You can have a floor division also. So I understand in a simple format. What is the meaning of floor division? Floor division actually check your quotient. Okay, so it is going to give you the quotient. Like 2 divided by 2 is 1. 3 divided by 2 is 1. Quotient, you can find out the quotient of that. Okay, so now let's see if I take a power of each. So the element from 0 to 9, each value will be power 2 this way. Okay, the next one is finding the remainder also possible. So like true division give you a true divide, the floor division will give you quotient, and if you write a remainder, it is going to give you each value divided by 2 and the remainder will be presented over here. Okay, now suppose if I take a 3 value minus 10, 12 and 0.3. This is the original array. I can find out the absolute value of that. Okay. Suppose I have the value 1.75, 1.55 and 2.55. I just want to round that. So that will be 2, 2 and 3 will going to come. Suppose I have a 0.38, 0.75, 0.54. I want to round off to decimal 1. Okay, after rounding off only one decimal will going to come. Okay, suppose I have array like this minus 1, 0 and 1. I can find out the sign hyperbolic of that. I can find out the inverse sign of that also. So these values I'm finding the inverse sign of that. I can find out the same value cosine values of that, cosine hyperbolic. I can find out the inverse sign cosine of that. I can find out the tan value of minus 1, 0 and 1. I can find out the inverse of that. Okay, tan operation, inverse tan operation. Suppose I have value 180, 90, 90 and 180. This is the values in degree. I can convert that into radian. So these are the radian value. This is pi, pi by 2, pi by 2, pi. So this is minus pi by 2, minus pi by 2, pi and pi by 2 and pi. I have other method also. Instead of radians, I can write degree to radian also. That is also going to convert the value into this format. Okay. Suppose I have np.py. So what is the meaning of np.py? It is minus pi by 2, plus pi by 2 and plus pi. I can convert that into the degree. I can have a radian to degree transfer also. Great. Suppose I have sine value. Okay. And I want to find out the sine of 0, 30, 45, 60, 90. Okay, you have to write np.pi divided by 180 to convert this value into degree. Otherwise, the answer will come wrong. Okay, so this is value which are created in term of sine 0, sine 30, sine 45, sine 60, sine 90. You can find out the cosine value also. So 0 cosine value, 1 cosine value, you can find it out. You can find out the 10 of 0, 10 of 30, 10 of 45. This is a trigonometric operation. Suppose you have a random value from 0 to 10, and I can find out the mean of that also using X mean operation. I can find out the standard deviation of that. I can find out the variation of that. Okay, great. So you can see so many operations has becomes very easy using NumPy. Suppose you have a matrix like this. This is not array. This is a matrix. Okay, you can see there's nothing written. Brackets are given. So 2 into 2 array. Sorry, 2 into 2 matrix. You can just multiply 2 matrix like this. Multiplication. Suppose I have a array like this 1, 13, 15 and 17. I just want to find out the difference between both of them. So 1 and 13, what is the difference? 12. What is the difference between 15 and 13? That is 2 and so on. So you can find out the difference is 12, the difference is 2, the difference is 2, the difference is minus 17. You can create the array like this 1 e raised to 1 e raised to 2. So it's 1 e raised to 1 is 2.71, e raised to 2 is 7.38. I can find out the natural log of that. Okay, 0, 1, 2 is come. I can find out the common log, that is log to the base 10, and even I can find out the log to the base 2. See, the things have become so easy using NumPy library. Okay, so now I have suppose array like this, and I can do a element wise arithmetic operation also. So I can add that, I can subtract that. Each element is been added, each element has been subtracted, each element has been multiplied, each element has been divided by each element. Okay, and I can find out the square root of that each element also. Okay, great. So now suppose I have two numbers. I'm going to take these two numbers from user itself, and I'm going to find out the LCM of that. So suppose if I take a 4, press enter, then 5, press enter. Okay, the 20 is the LCM of that. You can round off the value which is given by the user. Suppose that your bill is 45.67. You can just round off to 2 digits. Just press enter. Your answer will going to come. Okay. So I have taken 2 digit itself. So you can take 45.674 like this. Press enter. It's going to round off this way. Great. So now suppose I have the value and I can just convert into the flooring and sale value. See, let me write it down, then you will understand. Suppose 35.7. So what is the highest value in the 35.7? It is 36 and lowest value is 35 in that range. So when you take a floor, it will be 35 and the sale will be 36. And you wonder to see one more thing. Suppose if I take a 35.2, still the floor value will be 35 and the sale value will be 36. So it's not rounding off operation. The floor and sale will be the upper value and the lower value of that fractional value. Suppose you have two lists like this, I can convert this list into array and each element can be multiplied. So it is very difficult to do that in list, but it is very easy to do that in array. So I convert this two list into array and you can see I can multiply each element in the list very easily. So let's see a lot of next mathematical operation which are possible with NumPy. Suppose I have the value like this and I just want to find out the remainder. So each value will be divided by 2 and the remainder of that will be found. Okay, the first remainder, second remainder and so on. I can copy the sign of one value to other value. Okay, so minus 1 sign will be copied to this. I can check whether it is a sign bit or not. If it is negative, it is going to say true, and positive, it is going to say false. I can check whether the number is infinity or not, or sorry, finite or not. Yes, it is finite number. Okay. I can just check out the LCM of that, was just writing LCM. I can just check out the GCD, that is common divisor of two values. I can find out the reciprocal of any value. I can find out the even reciprocal of a array. We can find out the cube root using numpy very easily. We can find out the square of each of the value in the array using numpy. I can find out the square of each of the element. I can find out the square root of each of the element. You can see the program which has already been written inside the numpy. We are using that. I can find out the log to the base 10, log to the base 2 of the elements, normal log, natural log of that. Okay, I can find the e raised to value, e raised to 2 and e raised to 3. I can find out the complex conjugate of that. I can find out the negative value of each of them. Okay, so minus 1, one negative is minus 1 negative will be 1. I can just find out the sign of that. So this will be negative sign, this will be positive sign. You can see minus 1 and 1. I can find out the absolute value of a complex value. Now this is a very special operation. I can find out the quotient and remainder at the same time. So you can see 0 to 5. 0 to 5 value is taken and each value is divided by 3. So these are the quotient and these are the remainders. Great. I can create the value from 0 to 5 and find out the power of each. Okay. So 0 to 5 I'm creating and each value have the power of 3. So again now I'm creating the 1 to 26, that means 1 to 25 reshape to 5 comma 5. So array of 5 comma 5 reshape is created. And now I'm going to take from 2 onwards everything and 1 onwards everything. So 2 onwards will be this part, okay, and 1 onwards means this part. So this row and column will be selected, not 16 and this part. Okay, you can check out this. So particular element also I can reach the third and 4. So 3 will be this and 4 will be this. So 20 will be selected. 3 will be this and 4 will be this. 0, 1, 2, 3. And 4 will be 0, 1, 2, 3, 4. Okay, great. I can take up to 3 and column from 1 to 1. Okay. So for 4, all elements 4, that means the row number 4 will be selected and all columns will be selected. The row number 3 and 4 will be selected and all the columns will be selected. Great. I can find out the sum of each of them, sum of all elements. I can find out the standard deviation of each of elements. I can find out the sum of all the rows. Sum of all the rows. I can find out the sum of all the columns also. Great. So now let's see more arithmetic operations which are possible with NumPy. So I'm creating the value from 0 to 9 array. And I'm adding the same array to the same array just to show you the addition operation. Okay. So each element will be added to each of them. You can multiply, you can divide. So 0 divided by 0 is going to say none. That value is missing. So 0 divided by 0 is not possible. So it is saying NaN, value is missing. Okay. So all elements minus all elements, that will be negative itself. Great. So all the mathematical operations which are possible with NumPy is been covered in this tutorial. I hope this is clear to you. Stay tuned. Thank you very much. This is Piyush Dave signing off.